Day is I went to look. I was looking on Twitter for something, and I was like, "Yeah, what episode are we on?" So I went to look through the Twitter feed or whatever, and dude, they take down the feed after so long, like it doesn't stay up. That hurt my feelings just a little bit. So you can only see back like, oh shit, the TV. Oh god, dude, that's my fucking uncle.
That
Um,
sound like he listening to like a old
he is, dude. That's
musical,
what happened when you got
like the
fucking.
violin.
Dude, he old. Hold on, let me see. Let me see if I can. Let me see
I
what I can
thought
do.
I
Dude, you
thought he was
old.
playing like records or something in the back.
Nah, man, that's his fucking TV. Hold on, give me 2 seconds.
Uh-oh. Not
Um,
in the first minute.
huh?
Not in the first minute.
What? Not in the first minute. What happened?
You were
We
saying,
been done gave up on that, Jamil.
oh, did we? Oh.
You came up on what?
I thought we
What
was
happened?
You
watching
was
the
just
house.
cursing 30 times talking about your uncle
Oh,
and how old he was in the TV, even though you old, just like him.
Facts
all
though.
right. Hold on. Let me see.
He over there know what episode it is, down to the time in the show, what's going on right now based on the music.
All right. Hold on. Let me see what we could do. We got it coming. So I got somebody on it. You know what I'm saying? I don't want to bring somebody else up here. I want to bring. So he got a crunk sister and a chill sister. So I called his crunk sister to have it turned down.
Not you told on him.
I 1,000% told because when I go in there and I said, "Hey yo," you know what I'm saying, it'd be a whole situation. What's up, Cree Cree? You know what I mean? It'd be a whole situation. All right, how y'all feeling, man? What's cracking? I appreciate all y'all. What's up, X? How you feeling, cuz? What the
Feeling
hell?
feeling good, bro. How you feeling?
You know, I'm tall, dark, and handsome in these streets. AF baby, who is that in your profile picture?
This from last week. This Angel Reese and her brother. They're 6'3" and 6'8".
Do her brother hoop too?
Yes, he does. I forgot what college he goes
Oh, he younger than her.
to. I
Is
don't know. He may be older and he may have graduated already, but I do know that he plays or played or maybe he is younger.
oh,
I don't know.
okay. Is he league bound?
X and Chop would know better than me. I don't.
Oh, all right. All right. What's going on, y'all? Marty, what's up, bro?
What's up with it?
You resting or you rolling?
I'm rolling.
How much time you got?
I don't even know.
Yo, is that me? Y'all hear that?
I thought that was a chopper.
All right. It sounds like somebody's lighting up the goddamn trailer, bro. That's messed up. All right. Let's see who up in this joint. Five Brooklyn girl. What's up, Ramona? Creaky checked in. Yo, check in the chat, man. Let me see who in the building. Let me see who I got with me right now. Um,
Oh, I gotta
yeah,
tell
let me
y'all
see who I
something
got
real
with me.
quick.
What
Now
you
that you
got?
all is here, y'all, guess what? If y'all use
What?
Kerrygold, it's a class action lawsuit if you bought that jump before 2023 because they was lying when they say pure on the packaging because the old packaging used to have forever chemicals that was leaching into the Kerrygold.
Shut
So
up.
I
Oh
promise you.
Lord,
So
What's Carrie
this
Gold?
Kerrygold is like butter. Kerrygold butter.
it's
You use
Irish butter,
seafood.
right?
Yeah.
It's for you.
Mhm.
It's for you. You eat it. Okay.
Mhm. So yeah, y'all go ahead and make sure y'all step in Wednesday or Friday because we'll have more details on nigga dudes. But yeah, I just heard that and I was
Wow.
like, oh my gosh,
I
because
thought
I
it was
be
a
using
hair
Carry
product.
Gold. No, it's
Dude, how you
better.
know? How you not know about Kerrygold butter? Kerrygold is the like it was the tip top of butter. Like
I ain't never heard of that, bro.
that shit was $7 for like 2 sticks, bruh.
Wow.
Kerrygold is expensive. That's what I was going to get when I found the Amish butter. I had
Okay.
Kerrygold in my hand, and I looked and I saw Amish butter. Amish butter. Ooh. So I put the
That's
Kerrygold
what's
It
down and I
was
up.
picked up the Amish butter.
it was a
Shout
whole
out to Ed
kilo
Baby
of
for
Amish
breaking
butter.
the news. Go get on that. Go get on that class action, y'all.
I
Mm.
will indeed claim my 76 cent. I'm here for it.
That's all you can get.
Swear to God, I will indeed claim my
76
76
cents.
cents.
It adds up. Oh, and Miss
Hey,
Jason
you
is
know,
contaminated.
It do add up because I'm not gonna lie to y'all. I got like 4 little class actions that was like, oh wow, I still got $50 from this and $30 from this and $7.70 from that. So
Allie, you one of them people that be goddamn uh signing up for all the class action lawsuits.
like you evil twin, yes.
Dude, you know, it's ain't it a lady on like TikTok that be telling people how to sign up for all the class action lawsuits?
There's a
I
bunch of people
don't
that be
know, but
doing
I'm gonna
that.
find her.
that's Ali's
I'm gonna
sister.
find her.
Dang.
Oh God. All right, y'all.
Wait, why ain't nobody
Hmm.
tell me that Brittany Griner was married, first of all, and that that they having a baby? Where was I
What man and woman don't get
You was
together,
in
get
the
married, and
same
have
place as
kids,
me because I
Jamila?
ain't
What's
know
wrong
that.
with you?
I ain't know that
What,
either. Jesus.
what man
Bruh,
and
I
woman
was like,
don't get together and have kids? What's surprising you about this,
hey
Jamila?
man.
Hey, yeah.
Huh?
I'm
That
waiting for that better be in the segment today. Hey man, that's a dude. Okay? It better be in there.
I know. We haven't had that segment in a
bruh.
minute. What's
We
going
have.
on?
We had it
Really?
one day
Oh, I
you
be
was
sleep.
asleep.
Sorry.
It's
Sorry,
funny.
y'all.
Come on,
Hey man.
Jamila. Like
That's a
well, why are you
dude.
surprised? Like,
I didn't know I didn't know. It's
dude,
just
what? Well, dude,
yeah.
she's a dude. It's a woman married to a man. They having a
It
kid. Like, this is the
definitely looked
most,
like a man. Definitely looked like a dude.
bruh,
Definitely looked like a dude. I ain't even gonna hold you. There ain't nothing feminine about sis.
bruh. Like, what are you talking about? Like, there's nothing surprising. I saw it and I was like, oh, okay, yeah, that's about right. Like I said, I showed last week. I showed who was that? KD. Like when Brittany Durant Griner kissed KD, and he was like, "Hey yo, like no, that ain't the reaction you have when a woman kisses
I'm
you."
Yeah,
screaming. Why
I
did I not
definitely
realize
remember
that was
that.
Brittany Griner kissing him? I thought that was a random man. Like, no
Hey
funny
yo.
SHIT. Like, I really, when we watched it last week, I was
Ah,
like, who
ah,
is that
ah,
man?
ah,
Like, no
ah.
funny SHIT at all. Like,
Mm,
wow. That was Brittany Griner.
yeah.
Okay.
I was just in shock and I didn't I mean, like I'm just looking at the feet. Like what? Like and then they have a back shot her like she's like holding the wife's belly. And it's a cute picture, but I was just like, huh? Having a baby? Oh, wife? Oh, okay.
Yeah, like what the hell be? What the absolute hell?
I don't know why you surprised about her having a wife. She played in the WNBA.
Yeah, buddy.
What? What? So you trying to say that all women in the WNBA is
Not all of them, but most of them. It's even a story about one girl they made retire because she wasn't, so they kept bullying her.
shut up?
I swear
Oh,
to
that's
God, X know her name. I
terrible.
can't remember her name.
Mm,
Yeah, it gets rough for straight women and playing basketball. It gets rough. Like you got to
that's
be
a
really
shame.
solid in your joints. You got to be really solid, like because they do a lot of traveling together. They be in hotel rooms together. Like, yo, I hear it gets really aggressive from like the lesbians. Be like it's the same. So
Them bulldaggers gonna get a hold to you.
yeah, buddy. And I don't know if you could say that on YouTube, but you know,
Yeah, yeah.
we don't call them bull
Hell
daggers.
no
We
to the
call them
no
truck
no.
drivers. You know what I'm saying? We call them truck drivers, Marty. You know what I'm saying? Yes, and yes, the truck drivers are quite aggressive. You know what I mean? All right, y'all. What's cracking? Did everybody check in the chat? What's going on, everybody? How y'all feeling, man?
Hey,
We gonna like we gonna get straight to it today because like it's a lot. So what we're gonna do is so I did a presentation in a group like a couple weeks ago. I did this presentation, right? And I tried to make it to where you guys could hop on Rumble and watch, but we had some technical difficulties, so it didn't happen, right? So what I was going to do, I was going to just because I got the video for it, like I did it on Zoom. I did this flat earth presentation on Zoom, right? And so I was going to bring the video and just kind of literally go through the video, right? Look at some of the highlights, some of the stuff that was interesting, right? But I didn't even get through the whole presentation. That's how it was interactive. It went for 4 hours. 4 hours, and I didn't get through it because people was asking questions and they wanted me to stop. We're like, hold on, wait, I need you to clarify this, clarify that. So it was a scene, right? So what I'll do instead is I'll walk through the presentation. All right. So that's what I'm thinking about doing. Let's just I'll do the presentation for you guys. I'll walk it through. It's essentially just like a beginner's course for flat earth. All right. So if you know anybody that you think may be interested in it or may have questions about it, this is the time to get them in. This is the show you want them to see, right? I'm going to start at the beginning, and I plan on walking just kind of regular, slowly, regular speed to slow through some evidence. All right. So this is kind of a flat Earth basics course. I'm using a lot of video from a lot of different places. Shout out to everybody who put up all the videos that I'm using. Shout out to the homies on Twitter, or what y'all call it, X. Shout out to the Flat Earth gang on Clubhouse. Everybody on YouTube, all the homies on YouTube. The Flat Earth community is amazing, right? And they're forever putting up videos, putting up content, experiments, observations. And so I'm pulling from a lot of those different places, right, to show you guys a lot of different stuff. All right. So that's what we're doing today. All right. I don't want to wait. I'm not going to do the normal thing where, we do some other stuff, then we get to it, because it's a lot. And even starting now, I don't anticipate getting through the whole thing. All right. So this might be a 2-week thing. So we'll see how it goes. All right. Let's see. Let me see. Before we get started with that, let's do this. Before we get started with that, y'all know my favorite. We got to start with this, man. Yo, it is what it is. So I want to remind everybody, don't spend your life looking at lasers, bro. Don't spend your time focused on the laser, right? Keep your eyes on what's important, right? Go to the root cause, right? Don't get distracted by the laser on the ground, all right? So that's my disclaimer to everybody, man. I want y'all to because that's what this is. If you're here hanging out with us, remember we're live. We do a podcast on Clubhouse. We're live Wednesdays and Fridays. So if you like this, by all means, come hang out with us on the Clubhouse live on Wednesday nights and Friday nights. The name of the house on Clubhouse is The Painful Truth. All right. Cool. Y'all gotta forgive if y'all hear that TV in my background. It's kind of loud. I'm trying to get it cut down. We'll see how it goes. All right, but we ain't gonna let that stop no show. All right, what up, Dre? What up, Lisa? I see you over there. Miss J, how you doing? Was that Wasi? Hold on, man. That's like 5 people. Where everybody else at? Check in the chat, man. What's wrong with you people? Also, hold on, before we get started, make sure we got a rep the fam. Hold on, where is it at? Go ahead, rep the fam. Remember, blackistheuniform.com. Blackistheuniform.com. The Conspiracy Corner is lit. It's one of my favorite shirts right here. All right. The Conspiracy Corner is lit. And because we're finna do a Flat Earth conversation anyway, a Flat Earth presentation, the Flat Earth Gang shirts is here, man. Got the Flat Earth Gang hoodie, t-shirt, and some shorts, B. Like, what are we doing? Flat Earth Gang is lit. I survived the Great Reset, off the chain. This Einstein shirt is hilarious. If you like throwing chairs, this for all my chair throwers. Everybody like throwing chairs. You can't be afraid to throw chairs, man. You know what I'm saying? And so this is the Conspiracy Corner. Don't forget, besides the Conspiracy Corner, you got Flat Earth University. All right. Flat Earth University is lit. This is for all my conspiracy people, man. All my critical thinkers. We're in the building. All right. Don't be ashamed to rock it. All right. Don't be ashamed to rock it. All right. All right. Let's see where we at, man. Where we gonna start this thing at? You said let Granny. You know what, Miss J? That's not even Granny. That's my uncle. Granny is all the way in the back. If that was Granny, I would have went and cut it down. All right. But it ain't Granny. All right, let's get this thing.
Miss J. He used to go get the switch and whoop him when he was a little kid.
Man, look. You ain't anyway, don't get me started with that. Anywho, all right, so let's get going. For the most part, here, let's start it like this, right? I want everybody to put in the chat, right, some of the reasons that you think that not you, because most people here already know, right? I want you to put in the chat reasons that you think the Earth was a globe. Like when you did think it was a globe, you know what I'm saying? Because I know most of the people here already know better, right? Because you guys are, graduate level conspiracy students, right? So when you did think it was a globe, what were some of the main reasons that you thought that you lived on a spinning ball? All right. Put them in the chat. All right. Let's see what we got. If you're on, don't forget to check us out. We're on Rumble at 10-4 Fam on Rumble. On Twitter at TINF Cookout. TINF Cookout. That's where we are on Twitter. And YouTube is 10-4 Family. All right. So we're on all those platforms. Make sure you check that out. All right, what you say, Ms. J? They indoctrinated me from pre-K on to college. Facts, right? So one of the reasons is, school, right? It's something that we were taught in school. That's a very, very good one. What else you got? Right, Jamila, what you got? What
What's
you
the
got,
question?
Jamila? Why did you believe the Earth was a globe?
Oh, I just always did from school. Like I didn't have no other reason until we came in here and y'all niggas was like, nah. Well, actually, I'm not gonna say that I didn't. Like I stopped believing before we came in and met y'all, but it just didn't seem right. Like what they were saying, like when they start just history in general, But yeah, from school.
All right. Jamila says school as well, just like Miss J. Eureka said because the sun and the moon are both. Well, Eureka said
we learn it from.
So you know what? It depends. Like, it's a lot of places that you learn it from, right? Some people take biblical cosmology over what they learn in school, right?
What I'm saying is like it's pictures, like so you automatically see it. So it's like you're looking at the pictures, you're looking at the maps, like you know what I'm saying. You're looking at the globe because we had the globe that you would turn, like and roll. So it's like that's what it was. You know, you looking at the solar system and learning about the everything was round and it just went around. So
Right. That's what Eureka said, right? So the sun is round, the moon is round. So hey, the earth is round, right? So that,
but
even
only
before
because
you
we
get to
saw it. Like not
yes,
just
the
because
thing
we were
is, even
told
before you
that.
got to school though, even before you get to school, you seen it on TV, you seen it in movies, you seen it on cartoons. So some
Right.
people
But
got
that and
thought even before
that's
they get
yeah,
there,
and that's what
right?
I'm saying. Like the imagery that were
Mm-hmm.
shown. Like, oh, that's the
Yeah.
earth. Oh, good, okay.
Mm-hmm. So essentially, once when I actually go through all the reasons that people think that they live on a spinning globe or a spinning ball, it eventually boils down to these 5 reasons, right? School, number one, right? The first day of kindergarten, you walk in, yo, they got the globe right there on the desk. You get to spin it, touch it. They start telling you about solar systems and stars and suns and shit. And yo, you internalize it. The second thing is observations, like Eureka just said, yo, I see the sun, I see the moon. Hey, they're round. This must be round. It's just consistency. So people make observations. The third thing is NASA, right? NASA is a huge propaganda company. That's all they do. Their entire reason for being is propaganda. And so you get photos from NASA talking about satellites and the James Webb and other planets and the Drake equation and all this other stuff. So NASA gives you all kinds of stuff. The other thing is what I just talked about with the media, whether it be movies, right? Star Trek, Star Wars, Stargate, right? Deep Space Nine, all of that good stuff. The TV stuff you see on the internet, so all the media is always pushing heliocentric space propaganda from start to finish. Okay. And the last thing, which we deal with a lot in the conversation, is somebody told me so, which that's what it boils down to when people get the quoting. They get the quoting people that they deem an authority on the situation. Well, I know a guy, he's a PhD in astrophysics, and he said, well, Neil deGrasse Tyson was on TV and he was doing an interview, and he said, so some authority figure essentially just told you, hey man, look, this is what it is. You got gravity, you got quasars, you got stars, you got light years. Einstein came with some bendy space time, right? Oh man, this is the bending of space time. Yes, they warp space time. The question is, how the hell do you do? So I want y'all to think about this, right? They took something that had no physical form and they reified it, right? They took a abstract concept and just made it. They made it physical. That's like saying, oh yeah, you know what? I grabbed some love red yesterday. Like what? Like, yeah, no, I got some love red. Love red? Yeah, like I took some love and then I mixed it with red and now it's just love red. Like, yo, what the hell is that? That's the same thing as bendy space time, right? So, these are the main reasons. Like whatever reasons people put up whenever I ask this question, they fall in this category. They all fall in this category. Okay. So just so we understand, there is no, like, since the beginning of time, there hasn't been a consensus on what the earth actually is. Most people think that, oh no, the Catholic Church did this, and when Copernicus came and Galileo, and now everybody thinks it's a globe. No. Right now, today, there are lots of people who have serious questions about the model of the world that they're given. Okay? And so I want to read to you guys some quotes from people in the science field that are calling into question the model. Right? So it's not an open and closed case. It never has been. And so that's something I want to lay out there so people can understand. This has never been a case of, oh no, this is what it is. There's scientific consensus, and that's what it is. What you say, Mr. Tummy? You can measure curvature yourself. YouTube measuring Earth's curvature with basic gear, no flat. Yo. All right, we'll get to some of that. Don't go nowhere, Mr. Tummy. I'm interested to hear what you think. So this is from astrophysicist Ashok K. Singhal. The apparent alignment in the cosmic microwave background in one particular direction through space is called evil because it undermines our idea about the standard cosmological model. The Copernican principle seems to be in jeopardy. The Copernican principle is the heliocentric model, aka big sun, little earth, everything goes around the sun. All right. This is Jonathan I. Katz. No longer could astronomers hope that the Copernican dilemma would disappear with improved data. The data were in hand and their implications inescapable. We are at the center of a spherically symmetric distribution of gamma ray burst source. And this distribution has an outer edge. All right. So again, more doubt about the Copernican model, and this time he's citing evidence. Whether the Earth rotates once a day from west to east, as Copernicus taught, or the heavens revolve once a day from east to west, as his predecessors believe, the observable phenomenon will be exactly the same. This shows a defect in Newtonian dynamics, since an empirical science ought not contain a metaphysical assumption which can never be proved or disproved by observation. This physicist Dennis Sciama. So pretty much he's saying that, hey, whether the Earth is rotating from west to east or the sky is rotating from east to west, it would look the same to us. We wouldn't be, we couldn't tell the difference. Okay. And so this is one of my favorites right here. This is George F.R. Ellis. He's a physicist. He says, I can construct for you a spherically symmetrical universe with Earth at its center, and you cannot disprove it based on observations. You can only exclude it on philosophical grounds. In my view, there is absolutely nothing wrong with that. What I want to bring into the open is the fact that we are using philosophical criteria in choosing our model. A lot of cosmology tries to hide that. Essentially, what he's saying is the heliocentric model is a belief system. Right? That's it. It's just a belief system. It is not based in science. Because using observations, you can easily construct a model with the Earth in the center and everything going around it. And remember, every observation that constructed the heliocentric model, the globe model, all those observations were made from the ground. Okay? They're made from the ground. Meaning that they weren't made from a different vantage point than what every one of you looking at this presentation right now, every one of you have the same vantage point that was used to make the globe model. Okay. Let's see. Hold on. Yo, is this dude spamming my chat? Hey, bro, you gotta relax, Mr. Tummy. All right. I want you to hang out. Just don't spam the chat. All right. Let's see. So let's get back to it. So the Michelson-Morley experiment. Okay. Now, this was the experiment that fundamentally changed physics. Okay. Michelson-Morley is the one that did it. The Michelson-Morley experiment is the experiment that was the reason why Einstein became famous. He became famous because of their experiment right here. All right. The Michelson-Morley experiment confronted scientists with an embarrassing alternative. On one hand, they could scrap the ether theory, which had explained so many things about electricity, magnetism, and light. Or if they insisted on retaining the ether, they had to abandon the still more vulnerable Copernican theory that the Earth is in motion. To many physicists, it seemed almost easier to believe that the Earth stood still than that waves, light waves, electromagnetic waves, could exist without a medium to sustain them. It was a serious dilemma and one that split scientific thought for a quarter of a century. Many new hypotheses were advanced and rejected. The experiment was tried again by Morley and by others with the same conclusion. The apparent velocity of the Earth through the ether was 0. So this was the experiment that proved to the entire scientific community that the Earth did not move. Okay, this is it right here. And so, so essentially what they were saying was, like, everybody knew there was an ether because there are waves, right? So I know what you're saying. What the hell does that mean? So it's like, how do you have, so think about, you're at the beach, you're looking at the ocean, right? And you're seeing the waves, right? Surfers riding the waves crashing in, right? Imagine getting rid of the water and still having waves. It doesn't make sense, right? Once you get the water, it's what's waving. And so for them, the ether is like my best way to describe what the ether is it's the canvas on which the universe is drawn. So if we were fish, ether would be the water. Ether is everything around us. So when people talk about waves, radio waves and light waves, the ether is what's waving, right? You can't have a light wave without something to be waving. A wave is not a noun, it's a verb. And so the Michelson-Morley experiment proved that the Earth was not moving inside of the ether. And so they brought in Einstein, and Einstein's entire his idea was, well, you know what? Let's just say that there is no ether. So that's like going to a bunch of fish in the ocean, like, hey, yo, we just discovered that, this reef isn't moving in the ocean. And then another fish comes and says, well, you know what? It is moving. It's just that there's no water here by which you can tell that it's moving as a reference frame. You know what I mean? Like that's essentially what the Michelson-Morley experiment, that's what Einstein did. His idea was to say there is no ether. And that's like telling fish, no, there is no water. There's no such thing as water. All right. Let's see. Here we go. Let's do a couple of more. This is physicist Bernard Cohen. There is no planetary observation by which we on Earth can prove that the Earth is moving in an orbit around the sun. These are physicists, right? These are people in science. These are Einstein's peers, Tesla's peers, saying that, we don't know if we're moving. We could just as easily be still and the sky is moving. And this is known. We can't feel our emotion through space, nor has any physical experiment ever proved the Earth actually is in motion. Got it? The data of the Michelson-Morley experiment were almost unbelievable. There was only one other possible conclusion to draw. The Earth was at rest. It's another physicist. all these people are saying, yo, the experiment that was conducted, oh my God, it proves that the earth is not moving. All right. This is Einstein right here. I have come to believe that the motion of the earth cannot be detected by any optical experiment. Did you listen? There is no optical experiment that can be done to prove that the earth is moving. So anybody telling you, oh yeah, they just all they did was look at the transit of Mars and they used that in the transit of Venus to tell the size of the sun, that is impossible. There is no optical experiment that can be done to prove the earth is in motion. And this is the last quote from Einstein. To the question whether or not the motion of the earth in space can be made perceptible in terrestrial experiments, we have already remarked that all attempts of this nature led to a negative result. Before the theory of relativity was put forward, it was difficult to become reconciled to this negative result. Meaning that before I came up with the idea to tell fish that water didn't exist, there was no way to tell if the earth was moving. All the experiments done to prove that the earth was moving came up with, no, it's not moving. And so there's like, oh, you know what? Either we can just say the earth ain't moving, right? And we have to deal with that. Or we can come up with a reason why we can't detect it. And that's where Einstein's theory of relativity came in. Well, where he said, well, you know what? There is no ether and all the motion is relative, meaning that everything is moving in the exact, moving just the right speed and distance to where you can't really tell that it's moving. So you see, it is moving. And that's essentially what Einstein did. That's what he's famous for. All right. Anybody got questions about anything I said so far? No? All right. Let's see. All right. So essentially, this is at its core a scientific discussion. All right. We like to have it in the scientific realm using experiments. And so what I plan on doing today is trying to keep it as close to scientific as possible. All right. So what I'm just going to run through observations and experiments to show the stuff that we're talking about. Right. To show, all right, well, if we don't live on the globe, what's the evidence that we don't live on the globe? Besides a bunch of fucking physicists saying, you know what? We don't know if the earth is moving or, you know, like we can't really tell. All right. So when it comes down to experimentations, right, it comes in three categories, right? The way that I look at experimentation in this manner is three categories. So the first category of experiments is works on both models. All right. So I can give you several experiments that, it doesn't like, I can show you how it will work on a globe and I can show you how it would work on a flat earth. For example, the Eratosthenes experiment, right? So I can show you how it will work on a globe and on a flat earth, right? So on here it on? Here it goes. So here, this is the Eratosthenes experiment right here, right? On the globe, the sun rays would be parallel and Eratosthenes would take this angle, right? He would do some trig and come up with the radius of 3959. On a flat surface, on the flat earth model, the sun is small, earth is big, sticks, right? Get the same angle, right? Same angle. All right, and you do that, and if you don't know So remember, the Eratosthenes experiment assumes that these rays are parallel like this. However, we know sun rays don't come in like this. They look like this, right? So the Eratosthenes experiment works on both models, right? So we have a lot of things that work on both models, all right? The next bucket we have only works on the flat Earth model, right? So there are a number of experiments that I can show you that, hey, on the flat Earth model, yo, this is how it's explained. So we have, that's the second bucket. Things that only work if the Earth is flat and stationary. We have those experiments, okay? And the third bucket is only works on the globe. There is nothing that I have seen that goes in this bucket. There are lots of things that I can show you that go in these two buckets. I have seen nothing that goes in this bucket. And that's very important to me. Once I actually started looking into the flat Earth model, this is what I was looking for. Like, yo, I need exclusive globe only experiments. Can somebody find me some of these? And to date, I have never seen a globe only explanation. No, there's no experiment that, yo, this only works on the globe. All right. So that's where we are. So that's what I'm always looking for. And if somebody has one, I'm all ears. All right. I'm all ears. All right.
So wait. So Mr. Tummy says a globe only is a ship over the horizon. And see, and I don't agree with that.
No worries. We're going to talk about that in a minute. No worries, Mr. Tummy. We're going to talk about that in a minute. All right. No problem. All right. So like I said, this is a scientific arena. And so essentially what we do is we separate science, right, from pseudoscience, right? These two things are not the same. We must know this. All right. Let's look at some definitions, because in order to have a conversation, we must be talking the same language, and words must mean the same thing to both parties. So when I say science, science for me is defined as the systematic study of the structure and behavior of the physical and natural world through observation, experimentation, right? This is big, and the testing of theories against the evidence obtained. Meaning that it can't be science if it doesn't have an experiment to go with it. Okay? We need observations and experimentations. Huh?
That's the scientific method right there. You have to have
it. Is. Exactly. That's what we call science. All right? Now, pseudoscience, right? Pseudoscience, a collection of beliefs or practices mistakenly regarded as being based on the scientific method. Pseudoscience consists of statements, beliefs, or practices that claim to be both scientific and factual, but are incompatible with the scientific method. You get it? And this is the difference. And this is what we're going to focus on today. The difference between science and pseudoscience. Science has experiments. Pseudoscience does not have experiments. Anybody got a problem with that? All right. No? Cool. And then this is the scientific method, right? So we talked about this. There's an experiment. So just define the scientific method. It's define what an experiment is, right? An operation or procedure carried out under controlled conditions in order to discover an unknown effect or law, to test or establish a hypothesis, or to illustrate a known law, right? So this is very important in a discussion. All right. Often when we're having these conversations, we run across some very familiar fallacies. And so whenever you're having this conversation, no matter what side you're on, whether you're on the globe side, or you're on the flat earth side, we must guard against these fallacies. The reification fallacy, which I mentioned earlier, is a fallacy of ambiguity when an abstraction is treated as let me start over. A reification fallacy is a fallacy of ambiguity when an abstraction is treated as if it were a concrete, real event or physical entity. Perfect example, what I said before, space-time. Space is not a physical thing. You can't hold space. You can't put it in your pocket. Nobody can loan you some space. Time also is not a physical, tangible thing. This is a concept created by man. And so when people talk about, well, they bent space-time, what they're saying is they took things that were non-physical and made them into physical things. They reified them. That's called a reification fallacy. When you take something non-physical and you give it a physical attribute. Bending space-time is the perfect example of a reification fallacy. There's no such thing as bendy space-time. All right. Circular reasoning fallacy uses circular reasoning to support an argument. More specifically, the evidence used to support a claim is just a repetition of the claim itself. So if I say something like, yo, how do you know that refraction can lift how do you know that refraction can lift an entire skyline from behind a curved surface? And then people will say, well, see, look, it's doing it. What evidence do you have that refraction can do it? I'm looking at it across the lake. No, we're talking about the lake. That's the thing in question. You can't point to the thing in question as evidence for your claim. That's circular reasoning. All right. And the one that I probably hear the most is the appeal to authority fallacy. It occurs when we accept a claim merely because someone tells us that an authority figure supports that claim. An authority figure can be a celebrity, a well-known scientist, or any person whose status and prestige causes us to respect them. All right. And the last fallacy is the ad hominem. This fallacy occurs when instead of addressing someone's argument or position, you irreverently attack the person or some aspect of the person who is making the argument. The fallacious attack can be direct to membership in a group or institution. All right, that's called ad hominem when you start talking about the person. All right, so are we good on this? So everybody's good to go. So we laid down some ground rules. We looked at some things that are very important. So let's see where we gonna start. So I want to start with let's start with everybody's favorite reason as to why. So generally when we get to talking about why, or once we get to talking about kind of the flat earth idea, the first thing anybody brings up when I say, because I always ask, yo, have you ever seen a picture of the surface of the earth? Or one asks people, have they ever seen the surface? Have you ever seen with your own eyes the curvature of the surface of the earth? All right. That's my first question. Mr. Tummy, have you seen the curvature of the surface of the Earth? I see you in the chat. You seem to be very active. Have you personally ever seen the curvature of the surface of the Earth, Mr. Tummy? All right. Have you? That's a question. You in the chat typing real fast, bro. I think you're doing the talk to type thing. That shit's lit. And so an honest person would say no. Mr. Tummy just said yes, and that's fucking hilarious. But an honest person would say no, I haven't seen it because no one's ever seen it, right? And so I'll say, well, why do you think you live on a globe? They'll say, well, NASA. That's the first question. I mean, that's the first thing out of everybody's mouth, right? And so for that, I think it's important that we look at some of NASA's greatest achievements, right? Let's see. Where is it? Oh, here it goes. Oh yeah. Let's look at some of NASA's greatest hits, shall we? So, because this is the institution that everyone points to when we get to talking about evidence of the heliocentric model, right? Everybody points to NASA. So let's look at some NASA stuff, right? So this is the entity that you're pointing to. Where is it? No, not this. This one? No, where is it at? Oh, this one. Here we go. Let's look at some of NASA's greatest hits. Let's see. All right, so this is one of my faves. Let's go here. Right. So look at this guy. So you see him? So
yeah, so that's where they
there
are.
was a fly. Hold on. There's a fly. Wait. Let me see. Let me rewind this. Hold on. Not this one. So there's gonna be a fly right here. Right here.
Oh yeah,
He's
you
gonna
can
smack
see
it
it.
down.
Yeah,
Right?
yeah.
In space. They're all sitting in harnesses, right? And my man is smacking flies down. All right. We got space flies. So we had space mice. Now we got space flies. All right.
When was this? When were these?
So this is a collection, like
Yeah, drop the
over
link.
over
Drop the link in the
years.
chat.
I got you. All right. Let's see. So I've showed you guys this one before. So the hat doesn't exist. The mic doesn't exist. This guy thinks he's grabbing the VR hat. He's looking off screen, right? Because on the screen that he's looking at, he's got the hat, but he doesn't have it. Like they're having some sort of fail right here. They're sitting in harnesses and they're trying to interact with those fake microphone and hat. Let's see. This one's cool. This one's something just failed. This something just failed. Right. This is the Chinese space station. The Chinese is pretty bad at it. We'll come back. We're gonna come back to the Chinese. Hold on. So my man here, his wire gets caught. You can see it. Wait, you can see it. It's gonna be right here. You're gonna see his wire. All right, you're gonna see it right here. See it right here? Look at this. See that? See this thing right here? That's part of his wire that he's in.
Why does it look so junky though?
Yo, because they're in the space station, right? Oddly enough, none of that's there. That's CGI. None of that's really there. They just make it look like that.
Right, but that's what I'm saying. Like, why does it have to look so junky? And then
because they want you to think that they packed all this stuff.
It's giving even her hair like
disheveled. Yeah.
What?
Yeah, disheveled. 100%. Let's see. For this one, oh wait, look at my man's shirt being pulled right here. That's because of the wires. Right? They're all sitting in harnesses, and his wires are goddamn pulling his shirt. All right. His wires pulling the shirt. Wires pulling the shirt right there. All right. So this is NASA. This is what NASA gives you.
So
right?
yeah,
These are
so basically, okay, so wait, let's just address some of these questions. It says, how would that confirm the shape of the earth? Well, I don't necessarily know if it's confirming the shape of the earth, but I feel like or think that it is making a case that the people who are presenting that the earth is round has some secrets of their own. So it's giving,
right.
how can we trust what they're saying about what they're telling us? I think that's the case
Right.
here.
Exactly. So this is more to impugn their credibility. This demonstrates that the people that give us space pictures, videos, that give us space information, research, these people are liars, right? These people are liars. And what we're doing is we're looking at their lies in real time, so that whenever we're having this conversation, no one ever says to me, well, what about NASA? What about NASA? Right? What about NASA? That's what this is for. All right. So this is a CGI overlay fail. Right? I don't want to hear anybody in this conversation say, what about NASA? That's what this is for. This is not about the shape of the earth, this video right here. This is about the credibility of the space agencies. So what you're going to see is the people here in the background are on different layers. If you know anything about like CGI and digitally altering things, you know, you do things in layers, like on Photoshop. The people here are on different layers than the background. And so you're going to watch them cut off the layer that they're on, but you see
I
the
didn't see
background
this
didn't go
one.
nowhere.
Oh wow.
All right. Different layers. All right. So this is the what about NASA? This is my favorite. This is my all-time fucking favorite right here. Pay attention. This is my all-time favorite NASA film. Watch this. Houdini. Watch my man leave. Houdini. He disappeared. He disappeared. See that? Let's go back and look at that. He freaking peered. All right. This does it. My man disappeared around the corner.
Fade into the background.
Right. Fade to black. Exactly.
Fade into the background.
Exactly. All right. Now this one is just as wild. So this is him. They cut the camera on too early before they were ready. So he was sitting in his harness in the stage or whatever, and they put him on, but the camera's already on. So they be making mistakes. They make lots and lots and lots of mistakes. All right. So this is for people who say, well, how did they do it? Great. If you ever seen the movie Gravity or any other space movie, they do it all the same way. Right? So these people are coming down. So he's not going sideways. It just looks sideways to us because of how they oriented the picture. But he's actually falling, being lowered down. Right? That's what you got to know. This is how they do it. It's how they make it look like this. Right? They're using your eyes against you.
I'm so happy that they've I'm laughing at the chat. I'm so happy that y'all was about to kind of correct that, but I'm glad that y'all corrected that and saw that. He's basically saying what you just came to the realization of, Mr. Tommy. But yeah, this is really interesting. Linnell, there's some of these I haven't seen.
Mm-hmm. Oh yeah. Let's see. So this is I like this because this is how they do movies. So at the top, this is her in real life, and this is what it looks like when you get to the theaters. All right. So imagine NASA has a budget of like $28 million a day. This is light work, and they have graphic designers on staff. Okay, they have graphic designers on staff. So imagine what they can do with damn the unlimited budget and the backing of the government. This is their job. NASA is not a governmental space agency. They're a propaganda arm of the government. Their entire job is to keep you thinking globe. This is what they do. Keep you thinking globe. Right? So while they're doing this, they got you seeing this. You know what I'm saying? And I know what y'all thinking. Well, NASA is the government, but it ain't only the government doing it, right? It ain't just the government. Hold on, where is it at? Hold on. Did I close it? It ain't just the government, right? So what about Elon Musk? Right?
What about putting a link in the chat?
Oh man, I'm in the middle of what you call it. Can I?
Come on, Grandpa.
Hey yo.
Multitask.
Hey yo. Because I closed down a tab that I didn't want to close down. I was looking for it. I'm like, yo, what the hell I do with it? It was one of the first ones. It's my favorite. Okay. So talk about what about Elon Musk? Right? So that's a private organization. That's not even the government. So you saying Elon Musk is in on it too? Well, let's see. This is your SpaceX Dragon launch, right? This is your SpaceX Dragon launch. This video is still up on the internet today because I had to go and look at it to confirm it. And what do we see here? See that?
Yeah,
Space
that
Mouse.
took me out.
Space Mouse, right? Space Mouse. I actually had somebody try to convince me. This is a freaking PhD physicist try to convince me that it's possible that a mouse could survive riding on a booster into space. I said, what?
What?
He said, yeah, it's possible.
What did he say? How is it possible?
He said, well, a mouse can hold his breath for 5 minutes.
5 minutes?
So, and the booster is hot and space is cold, but the booster is hot, so it wouldn't freeze. And so, yeah, the mouse can, it can survive for up to 5 minutes.
So it's not hot enough. Never mind.
Bruh, listen to me. This is your SpaceX right here. Right? So when you say, well, what about SpaceX? Go ahead.
After the 5 minutes, then what happens to the mouse?
Man.
He's gonna die and just float into space? Like,
yeah.
What?
According to him. He's saying that, the mouse held its breath for 5 minutes and the booster kept it warm, so it's cool. So what about the wind? What about the sound? The vibration would have killed it alone.
Right.
But he ain't trying to hear that.
What about the speed?
Bruh. What about the G, right? The G force. Hey, but this is Space Mouse, Allie. Space Mouse. So, when you say, well, what about SpaceX? My reply is, what about SpaceX? Right? This is SpaceX right here. All right. So I know what you're saying. Whenever we had this conversation, people say, well, are you saying that all space agencies, they're in on it? Everybody around the world can be in on it. America isn't the only country with a space program. Well, that's true too. What about China? They have a space program, right? So this is the Chinese space program, right? Well, they got water in space, right? Look at him. So didn't we just see this? Didn't we just see this? Did we?
If you don't show the Indian moon
Right.
landing, you fail me.
You said what?
If you don't show the Indian moon landing, you fail me.
Oh, bro, what you talking about? Hold on, let me see. This one? This one? The Indian moon landing?
Nah, that ain't it. That ain't it. The space invaders shit. The video game shit. That's my shit.
Wait, let's see. Hold on, let me see for you. Let me see. Hold on. See, is it on here? I just pulled it up. I thought, here it goes. There you go. Oh shit. Hold on. Give me a second. So when you say, well, what about the rest of the countries? They have space agencies. They've gone into space too. Is this what you're talking about? Is this what you're talking about? For reals? This is what we're talking about. Is this what we've descended to? Is this it right here? This is what you're claiming to be real. Huh? Like Marty said, it's Space Invaders. I used to play this game when I was like 8. I first got Atari. It was amazing. Right? This is what you're talking about. Got you. So yeah. So that's your those are your NASA. That's your NASA. Right? So the question is that a place we should be looking for science? Is that a place we should be looking for science? So whenever we have this conversation, I never, ever, ever, ever want to hear, well, what about NASA? Ever in the history of life do I want to hear about NASA? All right. So you know what? Even your pictures of Earth are fake. Even your pictures of Earth are fake. Right? There are no images of Earth. Well, no, there are images, there are no photographs of Earth. Okay? Even your pictures of Earth are not real photographs. What do you mean they're not real photographs? What do you mean? I've seen them. Right? When you look at your iPhone, the picture on your iPhone, that's not real. That's CGI. Somebody created it. What you saying, Mr. Tommy? The blue marble photo taken from of Earth, taken on 12/7/72 from a distance of about 18,000 miles. Really? Let's see what blue marble was taken with. Can you hear that?
Yeah, we can hear it.
No, I don't want to.
Hold on.
I don't want to fool.
Let me get. Here we go.
In 2000.
This is Rob Simmons. He works for NASA.
2002, Blue Marble 2.0. NASA's Rob Simmons made this, and it had wide appeal too. For example, it ended up as the default background on the iPhone.
I didn't even know until I bought an iPhone and turned it on and kind of did a little happy dance.
Simmons' job is...
It's primarily taking data and making pictures out of it.
That's what this is, a composite of data sets from several different instruments translated into a picture.
To us, the really cool thing was the data set. Up until that point, there was no realistic color map of the globe anywhere.
So the land layer here comes from
the moderate resolution imaging spectroradiometer aboard Terra.
And the tricky part here was the weather.
So we actually had to take clouds out.
They stashed the clouds for later, went onto the ocean. That came from an instrument that measures phytoplankton in the sea.
Where it was low, I colored it dark blue because they're low mostly in mid-oceans. And then where it's a little bit higher, it was like a little bit brighter green.
Then add the clouds back in.
There's a small problem with it because there's a very slight gap in between each orbit.
So some of those are painted on.
It is photoshopped, but it's has to be.
Then
there was another layer to sort of simulate the atmosphere.
And then there's this little bright spot.
It's called the specular highlight. So it's the reflection of sunlight off of water.
Those are the pieces, but you can't just slap them all together.
It just didn't look realistic. It looks kind of flat, or the clouds are sort of too see-through. So I just hit Command Z a lot.
There's artistry to creating the world.
What I imagine it to be. Unfortunately, I'm not an astronaut. I've never been to space, but I've looked at these images over and over again, trying to sort of get the essence of it. It is photoshopped, but it's has to be. It is photoshopped, but it's has to be.
So there you go. Even your own photographs of this place are not real. They are not. They're created. They're created. So you live on the earth and you don't even have any real photographs of it. You have images that people have created for you. All right. All right. So now that we've dispensed with the, well, what about NASA discussion? All right. So now that we understand that NASA has no credibility in this discussion, right? They give us fakes, forgeries, and lies. You know what I mean? Let's get to the crux of the argument. All right. But now we'll come back to that. The crux of the argument is the shape of the earth. All right. That's the crux of the argument. Is the surface of the earth curving? All right. And so for that, we look to some very, very simple things. All right.
Hey,
so what's up, bro?
You know what I just thought about?
Yeah.
In today's age of social media, you know how quickly an astronaut would have took a picture of the whole globe Earth and put that shit on Facebook or something if it was for real, a globe?
They would claim that, oh no, it's classified. Astronauts can't do that. They're really, they're really restricted in how they interact. You get people saying stuff like that.
I feel that, but somebody would have did it at some point by now. Fuck it. What they gonna do? Throw you in jail because you took a picture of the Earth?
Okay. He said, to be honest, all of this is not needed. Just share how you measured the flat earth.
Yo, what you mean?
That's what he said. He said, just share how you measured the flat earth.
You don't want to get in there. You want to talk about why NASA's lying? So again, I have to take away anybody's refutation using NASA as a source of authority. So that was necessary, right? So now we know that you can't bring NASA into this conversation. They're proven liars. Okay. So when it comes to the shape of the ground, right? Sphericity of the earth. They give us a target, right? So hold on, let's get some let me pull something up. I have the calculator here. Where is it at? Here. All right. Let me pull this one up. Okay, let's do, what is the now remember, the radius of the earth was derived by quote unquote Eratosthenes. Okay. And it was determined to be, here, let me show it to you. Let's get to the busy. Let's get to it. Let's see. I'm just going to do a window. I don't think I'm going to need audio for this. All right. So the radius of the Earth, they tell us, is 38.8, around 3959, right? That gives us a circumference. Let's see what the circumference of the Earth is. 24,900 miles, roughly 25,000 miles. Okay, so this is the circumference of the Earth. Now, if we're standing on a ball with the circumference 25,000 miles, right? That means that there's a curvature rate. Here, let's go ahead and do how they calculate earthcurvature.com, right? So here, Earth curvature calculator, right? So the Earth curvature calculator, this is the formula that they use to calculate the curvature. All right. We generally approximate this to around 8 inches per mile squared. All right. And so a lot of times people say, well, no, you can't do 8 inches per mile squared. Why not? Well, let's look. So 8 inches per mile squared means that you take the number of miles, you square it, and then you multiply it times 8, and that's the inches, and then you can convert that to feet. So here, let's go with so 8 here. Let's do here the 5 miles. So for here, it's telling you at 5 miles, the amount of curvature is 16.67 feet, right? So let's do the 8 inches per mile squared for quick approximations, right? So 5 times 5, 25, times 8 is 200, right? 200, that's 200 inches. 200 divided by 12 gives you 16 feet. It's 16.66666. So 8 inches per mile squared is a really, really good approximation for determining Earth curvature. If not, if you don't like that, then you can go to earthcurvature.com. There's another, Walter Bislin has an Earth curvature calculator. So these are the things that we use. All right. So this is what we use. So I like a rough approximation of 8 inches per mile squared. Or if you don't like that, you can always go to a curvature calculator. All right. Okay. So let's go to some sort of laser test. All right. So now we test across water because water doesn't have topography. If you're on land, then you have to deal with the land's topography. So land is rigid. And so it's going to go up, it's going to go down. You got hills, you got valleys, you got uneven surfaces. It's kind of tough. However, water, since the beginning of time, has been used to make things level because everybody knows that water is always trying to lay as flat as possible. All right. So a body of water is going to lay flat. Right. And a lot of times I say, yo, a body of water is going to lay flat. And then people are like, well, what about waves? Waves are a disturbance in the water. That's not a water's natural state. You go to any lake that's not being disturbed, the water lays flat. Okay. So this video here is a 10-mile lake. And because water on a globe, so now let's remember, water on the globe, where is that? So the water is always curving. The water is sticking to the surface. So it's curving along with the surface of the water on the globe. So that means we should be able to test the surface of water and measure its sphericity. We should be able to go and measure curvature drop, right? We should be able to measure this, right? At a rate of 8 inches per mile squared. We just looked at the actual formula. We tested out the 8 inches per mile squared versus the actual formula, and it was pretty spot on. All right. So when we go and look at laser tests, this water should be convexing everywhere on in the world to the shape of the globe. All right. So this is in Washington, Tacoma, Washington. All right. And it's a distance of 10 miles. So let's look. Let's go back to our curvature calculator and see what 10 miles should be giving us. At 10 miles, right, there should be 66 feet of curvature. 66 feet of curvature at 10 miles. Okay. That means that one person on one person on a shore looking across 10 miles, right, shouldn't see the other person. And if somebody is shooting a laser across the water 10 miles away, the other person standing at the shore should have to look up in the sky to see the laser going overhead. Okay. Mr. Tummy, if you're talking about a raindrop, then we're talking about, are you talking about a raindrop at rest? Because a raindrop falling is shaped by the resistance of the wind. And a raindrop that's sitting on the surface beating, you're seeing surface tension, and that tension is caused by the water trying to go downward and make itself level. This is science, my man. Right? If you really understand it, draw a free body diagram of a raindrop and see what the forces acting on it are. All right. Let's go back to here. So now we're at our lake. All right. This is the laser. All right. This is the laser. Now, even so right now it's at 7 feet. So on this curvature calculator, you can put in object height. All right. Observer height here. 7 is, let's say, 2.5 meters. Distance is in miles. Hold on. I think this is meters. How many meters is that? I gotta go look. It's 2 meters. They just put it. It's 10 miles. What is it in meters? Hold on, give me a second. They just put it here. It's 16.5. So it's what, 16,000 meters? Is that what we're talking about? I really want to convert this to feet. Can I convert this to feet? Where's the metrics? Yeah, okay, here we go. Total distance. Oh, it's miles. This is miles. I think it's 10 miles. Target size. Is it meters? Is it 16,000? We'll see in a second. Hold on. Target size, I think it was at like 2 feet. Let's see. Let's say 2 meters. All right, let's see. All right. So I think this is, what is this? This is total distance is 10. I think it's 6. This is meters. So 16,500. So 16,000. All right. All right. So at this point, it's saying that nothing should be visible, and there should be 9 meters hidden underneath the curvature. Right. So they're saying it's a 21 meter drop, which is around 66 feet. That's correct. Right. So let's go and look. So this is them seeing. Let's get to the video, right, when they actually seeing it. All right. So this is the laser. This is the person on the other side of the lake looking at the laser. All right. And they're showing you, even at this observer height, they can see the laser. All right. And they're going to keep going. So remember, this, where they should be experiencing 32 feet of curvature because of the observer heights. and they're not, meaning that this laser should be going over this person's head 32 feet. All right. And then he's going to do something even better, right? He's going to do something even better. He's going to reduce observer height down to like 1 meter. 1 meter observer height. This thing should be up here, 66 feet, right? It should be way up top. All right. Then look what he does. He gets down to 0. This is like 6 inches, and you can still see it right there, right? You still see the laser right there. Impossible. This right here is a globe killer. This is it right here. Then what does he do? He goes and gets in the water and makes the observer height 0. Damn near 0, like let's say 6 inches, right? This is it. This is the globe killer. This is what we're talking about. It's not curving at all. This light should be above his head 66 feet, and is not. It's right there, and you see it in the camera. So, Mr. What's your name, brother? Mr. Tummy. This is it right here. Did you say is this doc fake? Yo, what the hell? Hey, yo. So this is the thing, Mr. Tummy. You can go and do this yourself. You can go and do it yourself. That's what this is for. This is an experiment. They're showing you what they're doing, right? Say it again.
He kept saying he did the work himself. And Lamb, knock it off.
Yeah, no lamb slam. So this is an experiment. He documented it, and now he's showing you. Right? This is what it's about. Observable, testable, and repeatable. Experimentation. All right. So I know you're saying, hey, well, that's only 10 miles. We're only missing like 66 feet of curvature. You know, anybody could do that. Really? Well, let's go to Great Salt Lake laser test. 21 miles across. 21 miles. All right. Let's go ahead and get to it. So we're at the Great Salt Lake. All right. We're going to bring out the laser. Hold on. Let me move this out the way. Let's bring out the laser. Where's the laser? Let's look at some of the... All right. So, these are the specifics. Hold on. Let me go back to where he put it up in. All right. So, the eye height, the observer height was 5 feet. And they're looking across 21 miles. All right. 21 miles across. Observer height 5 feet. That means it's 223 feet of missing curvature. This is what should be hidden. Over 200 feet. All right. Well, let's go see. Let's see what we can see. All right, let's see. There it goes. There it goes, right there. All right. Over 200 feet of missing curvature. A laser across 21 miles. 200 feet of missing curvature. All right. 200 feet of missing curvature. So when people say, well, how you know it's flat? Because there is no curvature. What do you call a surface that doesn't have any curvature? Asking for a friend. What do you call a surface that doesn't have any curvature? What you say, Mr. Tummy? The smartest thing I can say is do the work yourself. Do not blindly follow others. Never in the history of anything have I said, follow me. I'm literally giving you the experiments that you can go and do yourself.
Well, he said that he did his own experiments to prove before that the Earth was round.
What experiment did you do, Mr. Tummy? Can you please post me a link to it? What did you do? By all means, tell us all. So, while Mr. Tummy ponies up, we'll go to, because, I'm always looking for great experiments. We're going to go to FE Core, right? Field Engineer Core. And they're doing Lake Balaton 40-mile laser test. It's a 40-mile laser test at Lake Balaton. All right. And they're giving you the laser height, 2.84 meters. The distance is 21.26 kilometers. Camera height, 1.2 meters. And this is what you see. This is over 800 feet of missing curvature. Over 800 feet. And it just keeps going. Over 800 feet of missing curvature. This is what we're talking about. This is it right here. This is the crux of the flat earth discussion. That's it, that's all. That's it, that's all.
So wait, so
All
in
right.
that image, it was the red was the quote unquote measurement of curvature, and then what, the blue was
No, I
disproving?
don't know what that was on the I don't know what the red was. I have to go and look again. Right? I'm sorry. Oh, this is the 21. No, I'm sorry. Yeah, this is the 2 meters, 1.5 meters, 40 kilometers. Here it goes right here. My bad. Yep. So target 4 observation location. Oh, so I guess this was somebody looking to see what was going on. Like this, somebody was observing from here, I guess. All right. So they did this 3 times. So they didn't just do it once. They came back different times throughout the year and did the same experiment 3 times. Right, to confirm it. So it wasn't a one shot, that's it. They did it 3 times. All right. Mr. Tummy, you said what? YouTube measuring Earth's curvature with basic gear. Yo, they actually built a laser.
I think was the video that he was putting in there to prove the experiment or something? That a YouTube video?
No, is that your experiment, Mr. Tummy? Huh? And you say on the flat, yo. So hey, now I'm confused, Mr. Tummy. So when I get to talking about NASA and showing how they're liars, you say, well, we don't need to know none of that. Show me how you measure the Earth. And now I'm literally showing you how we measure the surface of the Earth and how there is no curvature. And then you say, well, what about the sky? Now you're trying to run back to the sky. I thought you wanted to measure the ground. That's what we're doing. I'm measuring the ground because that's what we're talking about. We're talking about the ground. Why every time we start talking about the ground, people want to start pointing to the sky? All right. So, in addition to the 10-mile laser test, the 20-mile laser test, and the 40-mile laser test, we also have the world's longest Wi-Fi transmission. So this is the Guinness Book of World Records broadband wireless connection. So somebody sent a Wi-Fi transmission, right? Wireless signal, 237 miles line of sight. That means they have to see each other from 237 miles away. It was in, let's see, where were the two places? It was in in Venezuela, right? It was, let's see, hold on. I wrote them down. It was in the Andes. And so it was from the Platabon Mountain to El Guila, Venezuela. So the Platabon Mountain, and I'm just using the highest point in both of these locations. Okay, this is the highest point in both of these locations. It could have been even worse, but I'm being generous. So the Platabon Mountain is 6,229 feet up. The El Guila, Venezuela has elevation of 13,000. This is a mountain, 13,510 feet. The difference is 7,181 in feet. So 7,181 feet. All right. And so that being the case, here, let's go ahead and put it in our let's put in our trusty dusty calculator. The observer height is in feet. What's that in meters? I want to do it in feet. Let me see if I can do it in feet. Let's see. In feet, it's 7,181. The distance is in, hold on. Let's see. Miles, it's 237. All right. Let's see. 1, because this is the observer height. All right. Or, I mean, I guess I could put, and let's see. I'll put the actual distances here. So how about this? 63.29. That's one place. And this is, let's see if this will work. 5. What's that? 510. 510. I think this is right. Hold on. Let's see. No. So I think the so target size should be. Oh wait, hold on. Wait, no. So this should be 1, and I should just put the target size. I mean the observer height. Observer height. That's right. All right. So right. All right. So now we got the hidden 11,000 feet of curvature. So it shouldn't be visible at all. All right. And it transmitted. That's the world's longest transmission. World's longest Wi-Fi transmission. So now you got 237 miles. And then you have the world's longest photograph. Guinness Book of World Records, line of sight, world's longest photograph. All right. And I think so in this, let's see, the distance is 443 kilometers, which is like 600 miles. It's close to 700 miles. And all of this should be hidden with the exception of like the top of this right here. All right. And so it just keeps going on and on. Right. It just keeps going on and on. Like all of this right here should be hidden. You shouldn't be able to see none of this. All right. So it goes on and on and on and on. All right. When it comes to the line of sight observations. Anybody have any questions so far? I've been talking for legit an hour and a half. Anybody got any questions so far? Let's see. Valerie at Rumble in chat says flat. Oh, Miss J, what are you talking about? You just telling me what they talking about on YouTube? I mean on Rumble. Got you. All right. Any questions so far? Anybody got any that need to go in the chat? We're gonna pause for the cause. So I went through NASA and I went through the observations. Anybody got any other questions so far? No? Let's see. What should we get into next? Let me see. I don't know, Jamila, I'm gonna let you choose. What do you want to get into next? So we either have we can talk about gravity, we can talk about the sun, the moon, the stars, or just space in general.
But we got 20 minutes. So what can we do in 20 minutes?
You know what? Okay, how about this? In the last 20 minutes, this is what I'll do. Instead of getting into one particular thing, let me just talk about the model.
Let's sum this up. Miss J is saying bed. I said we might could sum this up in 10 minutes.
We can just talk about the model.
Anybody else that would be interested, yeah, come find us. We got, well, you'll say all that, but yeah, we got a whole group.
Yeah. We get busy on Clubhouse. Yo, if you like this kind of information, you like digging into conspiracies, come hang out with us on Clubhouse. The name of the house on Clubhouse is called The Painful Truth, and we're live on Wednesdays and Fridays. It's a whole scene, man. All right. So let me see. So let's talk about what I am saying, what I'm not saying. Okay. So what I am saying is that the entire model that you were given about what the world looks like is fake. All right. Hey, let me see. So what does that mean? Hold on. Oh, okay. Here, let's do this. Let's do this. Why are they trying to rush me? Let's do you know what? Let's do it like this. Make it quicker. All right. So what I am saying is this, that the entire idea of what you were given in school is fake. This entire model is a myth. It's something that they invented to keep you away from the stuff that we're talking about now. All right. The entire model that was concocted by Copernicus is fake. Right? So the sun is not 93 million miles away. It is not 938,000 times the size of Earth. Not at all. All right. These planets are not physical places that you can go to. Right? Has ever seen sphericity of any of these? You only see lights in the sky. Same thing with these little white dots right here, these stars. There is no evidence that this is physical thing, physical places you can go to. Okay? There is no asteroid belt between Mars and Venus and Jupiter. There's no astral belt, right? There are no moons of Jupiter that have things. There's none of that. None of that is real. Okay? That's what I'm saying. Most of the time when you see people, especially people who try to debunk flat earth, they'll show you this and then they'll just make the earth a flat pancake in the middle. That's what we're not saying. All right, so let me make that very clear. All right, so get this out of your head. Now let's look at what I am saying. So when it comes to the earth and the sun, what I am saying is the sun is very small and very close to earth. And the sun goes around the earth. And its light is very local. And so day and night are a product of the sun moving around the earth. Okay? That's what I'm saying. That the sun is very small and very close. The sun and the moon are approximately the same size, and they go in a circle above the earth. Now, don't look at the moon here. I don't like the moon here. Like this moon, I don't think it doesn't do this illustration, this animation, the moon is off. Now, the position of where the moon is, I think is what they're trying to show. But in terms of the moon and the sun being the same, no, don't look at the moon in this, just look at the sun. Right? And so this is how day and night happens. And so if I were to show you, so the sun it doesn't go just around one track the whole time. See these three different lines right here? The sun, as it goes around, it oscillates between these lines. So here, let me show you. In January, you'll see the sun is, it's hard to see, but it's closer to the outside. All right. Then let me see. Oh, there it goes. See how in January it's closer, it's on the outside. This is the Tropic of Capricorn right here. So this is around January, right? When the sun has just left the Tropic of Capricorn. So it's at the Tropic of Capricorn on December 21st. All right. And then it travels so in 3 months later, you're going to see it near the equator, which is this middle line right here. The equator is the midway point between the tropics. Tropic of Cancer, Tropic of Capricorn. See at the sun in March. This is your March equinox, right? That's when the sun is at the tropics. I mean, at the equator. I'm sorry. All right. Then we come along a little further. And the sun is, what's it? We in May. Let's come along a little further. June. Yep. Around June. So the sun is at the Tropic of Cancer in June. Right? June 21st is the longest day of the year. And I don't know if you noticed this, but the light profile on Earth has been changing as the sun moves. Right? You see it? So depending on where the sun is, how the Earth is lit up changes. Okay? And so the sun spends 6 months going from Capricorn to Cancer, and then the next 6 months going from Cancer to Capricorn. All right. So that's one of the things that is important to understand, because that's one of the first questions people have. Like, well, what about day and night? How do day and night work? How do seasons work? And so this is important to kind of understand. The first thing you have to do is understand the Earth is really big and the sun is really small. All right. Sun and the moon are really small. All right. Let's see. And so here, this is a good video to demonstrate here. Let's go back here. You know what? Let's stay here. Let's look at. Oh, so Shane, one of the homeboys, Shane St. Pierre, I think that's his name on Twitter. He hijacked a model or some code for a model. So if you ever kind of want to see like a complete understanding, so this is a really good rough like first draft. And so you can come here and you can play with this. You can mess with the day of the this is the time of day, this is the day of year, right? You can change the observer latitude, right? It'll show you kind of what you should see. You can zoom in. Excuse me. Camera height, all right? So you can tinker with this. This is a good kind of starting point to understand what we're saying is going on. All right. And so he kind of rolls down the purpose of the model. All right. So this is I'll drop this in the chat for you guys. So Shane St. Pierre, one of the homies on Twitter. Yeah, let me see if I can put this. What'd you say, Mr. Tummy? Is what CGI? I showed you an animation. It was just an animation, bro. All right. There's an animation. All right. So you know what? We can pause there for a second. We can pause there. All right. All right. How do we feel about that? Was that too much for one day, Marty? It was a lot. And this is why I didn't get to finish my my presentation. Like, I didn't get to finish the presentation. It's a lot more to talk about. All right. So this is the first in the series that we're doing. So we're going to pick up next week. We'll be back next Monday, same time, around 11:15 Eastern, and we'll get going and we'll get into gravity. We'll talk about the sun, the moon, stars, space, a lot of different stuff. All right, a lot of different stuff that I think people like have questions about. So essentially, like I said, I got a presentation I wanted to do to help people just understand the basics of flat Earth. So I think this kind of does it. All right, so I'm trying to make it as comprehensive as possible. I appreciate y'all hanging out with us, man. Remember, we're live on Clubhouse on Wednesdays and Fridays. Y'all, if you like hanging out and talking conspiracies, it's your favorite conspiracy cousins, man. Come hang out with us. It's always a good time. All right. And on the way out, remember, we do go to blackasuniform.com. Get your Conspiracy University, because this is Conspiracy University. This is university level conspiracy talk. You know what I mean? If you can't tell, this is university level conspiracy talk. So don't forget to go to blackasuniform.com and check out get your gear, man. All right. Other than that, man, it's been real, man. I appreciate y'all hanging out with us. Even people that don't agree, you ain't gotta agree with us to come hang out with us. Like I don't mind answering questions to people who have honest fucking pushback. You know what I mean? All right, y'all. So we'll see y'all next week. If y'all don't come hang out on the show, or if y'all don't check out the podcast. We out.